Welcome in another video. Today we are going to discuss the difference between endothermic and exothermic reactions. So let's consider the reaction between A and B to give C and D is an endothermic reaction. And if we to represent this reaction in a diagram, we would put the heat content or heat energy on the y-axis here and reaction progress on the x-axis. In an endothermic reaction, always the react, for example here A and B are less in energy than the products. So for example, the energy of the reactants, let's say at 5 kilojoules, right? Just random numbers. These are not actual numbers, right? And the product's energy at, let's say, 10 kilojoules. Let me write it better. 10 kilojoules. So if we to get the delta H of this reaction, delta H is all about H2 minus H1, or H products, let's say H products minus H reactants, or the heat content of the products minus the heat content of the reactants. So in this case, the delta H in this case would be, so the energy of the products is 10 kilojoules minus the energy of the reactants, or the heat content of the reactants, which is 5 kilojoules, then minus 5, then it is 5 kilojoules, right? So you could see the sign of the delta H here is positive. So the delta H of any endothermic reaction should be a positive value. So a delta H of any endothermic reaction should be a positive value, right? And this actually represents a heat transfer from the surrounding to the system. That means the system gained some amount of energy, right? But the vice versa occurs in the exothermic reactions. So here we have X and Y. These are the reactants. Z and W, these are the products. As we can see here, that we start with the reactants X plus Y to give finally Z plus W. We can see here that the energy of the reactants are higher than the energy of the products. Let's say the energy of the reactants here, 10 kilojoules, no problem. And let's say the energy of the products, 5 kilojoules. So if we to calculate the delta H should be, as we said previously, H2 minus H1, or H products minus H reactants. So let me write it briefly: H product minus H reactants. So delta H in this case, H products with 10, with 5 kilojoules, and H reactants with 10 kilojoules, right? So 5 minus 10, this is actually negative 10 kilojoules, right? So the delta H of any exothermic reaction should be a negative value, since the system loses energy to the surrounding, right? This energy loss, this is actually what we feel. So, for example, if you added a substance to another, two aqueous solutions to each other, and the reaction takes place, and when you touch a beaker or a test tube and you realize the test tube or the beaker got hot, that means energy released from the system to the surrounding. This is actually what you feel. This is actually an exothermic reaction. The vice versa occurs in an endothermic reaction, where, for example, you have a beaker or a test tube and you added like two components to each other, two aqueous solutions to each other, and then a reaction occurred. And when you touch the beaker or you touch the test tube, it gets cold. When it gets cold, this means the energy transferred from the surrounding of the beaker to the system, to the reaction mixture. So if we to summarize what we said, endothermic reactions express absorbing of heat energy, while exothermic reactions express releasing of energy. That's it. Thank you for watching. If you liked the video, please hit the like button, subscribe to the channel, and comment below. See you in the next video. Bye.